Hello and welcome to the next video of Python Byte series. In this video we are going to see the number conversion algorithm. So what is number conversion algorithm? Let us first see what are the different types of number systems. The first one is decimal number. In this we represent the number with the base 10, that is n to the base 10, and the digits that we use to write decimal numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So for example 39 can be written as 3, 9. The next number system is octal number. In this the n is written to the base 8. So this is how we write the octal number, and then there are 8 digits to write the number. So 0, 1, 2, 3, 4, 5, 6, 7. So from 0 to 7 the numbers can be written as the digits, but when we go to number 8 in decimal, in octal it becomes 1, 0. The next number system is binary numbers. So in this we write the number as n to the base 2, and there are 2 digits to represent the numbers. So, and binary is also a very important number system for computers, because that is how computers internally communicate. All our files, all our code are written in binary in computer memory. So for example, to see a binary number 5, it can be written as 101. Then the next one is hexadecimal number. As the name says, there are 16 numbers or 16 characters to represent a hexadecimal number, and it is written as n to the base 16. And then hence because there are no 16 numbers, we use 0 to 9 and A to F to represent hexadecimal number. So 0 to 9 are represented as the digits, and when we have to write 10 in the decimal 10 into hexadecimal, we write A, and so on and so forth. So F becomes 15 in decimal. So as we have seen the names decimal number, so deci means 10, so there are 10 digits. Octal, octa means 8, so 8 digits. Binary means bi is 2, so it is 2 digits. Hexadecimal is, hexa is 6, decimal is 10, so 16 numbers. So that is why there are 16 characters in hexadecimal, 2 in binary, 8 in octal and 10 in decimal. Now let us write a Python program to convert decimal number to binary, octal and decimal hexadecimal numbers. So if we have 100, it will be written as 100 in decimal, 144 in octal, 64 in hexadecimal and 1100100 in binary. So now let's start writing a Python program to convert a decimal number to binary, octal and hexadecimal number. Let us first understand the logic of how to do the conversion. This logic is going to be similar for all the bases. So I'm going to explain you for the binary over here. So now let us take the number. So the n is equal to 14 and the base is 2. So this is a binary number. Now let us start the operations on it. So how to convert it? So first we take 14 and divided it by 2. So when we divide 14 by 2, we get 7 as quotient and remainder as 0. This remainder is important, so we will keep writing it in our logic. Then we take the quotient from the last step and we again divide it by 2, 2 being the base over here. And when we equate, we get quotient as 3 and remainder as 1. Now we take the quotient 3 from the last step and we divided it by 2. And now the quotient is 1, remainder is 1. Now we take the quotient from the last step and divide it by 2 again. And we go till we get quotient as 0. So in this step we got quotient 0, remainder 1. So now over here we see that we have got remainder 0, 1, 1, 1. So 3 ones and 0. The conversion of number 14 in the decimal into binary is going to be the reverse order of the remainders that we have calculated. So we go from bottom to top. So if we write 1, 1, 1, 0, this is going to equate. So this is binary. I'm going to write binary is equal to 14 in decimal. So we have to implement a similar operation to find the binary number, hexadecimal number, octal number from decimal. So let me put this in comment because we are going to use this logic and we will implement it. So now let us declare a function called as def convert number, and this particular function is going to have 2 arguments. The first one being the number, and that's going to be an integer. So it's an integer input, and the second one is going to be base, and that is also going to be integer. The output is going to be a string. The string is the conversion of the decimal to binary, hexadecimal or octal. Now To do this operation, we are going to need a couple of variables. So in this function, the first one being the quotient. So we'll declare quotient as number, which we have given as an input to the function. The next one is going to be remainder, and that's going to be 0 to begin with, and then is going to be output, and that's we are going to declare empty string over here. Now we are going to perform the operation that we did in line 11 to line 14 in our code. So let us start the while loop. And how long the while loop will run? We have the condition that till the quotient is not equal to 0. So till that point the while loop will keep going. So we are, because in this while loop we are going to do operations on the quotient, we are going to save the value of quotient in a variable called quotient copy. So q, and we are going to do our operations on the quotient copy. So q is going to be quotient copy mod of base, not 2 but base, that we have given over here. In our example the base was 2, but over here we have to use a variable base, and the remainder is going to be quotient copy %2. This will give us the remainder of the division. If it's an odd number, we are going to get 1. If it's even, we are going to get 0. So that's only, so this particular 0 and 1 is only possible when it is 2, but we are going to declare it as base because we are going to have a general function which we can use for all the type of conversions. Now we are going to create our output or add the remainder to our output, and because the operation in line 27, that is the remainder, is going to be an integer, we need to convert that remainder into string and add it to the output. So we keep recursively adding in each while loop to the output. Remember that is not our required output. As we have seen in our example, we have to reverse the order in which the remainders are generated. So we will return a reversed order output. So return output, and we are going to use the, because it's a string, we can say that colon -1. This will reverse the output. Now let us see and run the function. So to run it, we will declare if name is equal to main. We will implement this. So this particular portion of the code will be implemented. So let us print. So this is our trial. So let us convert number. So it's going to be 14,2 because we have already done it over in the previous thing. So now let us run our code over here. So if we want to run, we just click over here, and it returns 1110, and that is what our example also we have done it, that we got 14 as 1110. So now we have created our function, but there is one little loophole or mistake or incompleteness in this function. If we use the base as 16, it will give us output as 41, and that is not what we are looking for, because we know that 14 in hexadecimal, that is when base is 16, is E. So we need to kind of create a map in our convert number function for hexadecimal, because hexadecimal has some extra characters that we have. So we will create a variable called hexamap, and this map is going to be a list, and list is of string I. So we are going to convert I, and for I in range 10, so that will give us 0 to 9, plus we will need 6 alphabets, that is A, B, C, D, E, and F. So this is our hexamap, and now over here we will create a condition. If base is equal to 16, that is hexadecimal, what we are going to do is we are going to replace remainder with hexamap bracket. We are going to give the place, because there are 16 numbers and they are serially ordered from 0 to F. We can easily give the index. The index is going to match the map. So we are going to give as remainder. So with this addition in our code, now if we run with 16, we are going to get E, and that is what is expected. So now we have created our convert number function, which will convert our any decimal number into binary, hexadecimal, octal, and any other base. But over here we are just going to use these 3 bases. And now we will write a function to write, because we have to write the final end of this code is going to be output n number. So if we are giving 14, we have to print the combination of octal, binary, hexadecimal for all the 14 from 1 to 14. So now let's write a for loop over here. So the for loop is for I in range, and we are going to we need to give an input over here. So let us take the input. So let's take n as our input, and let's say integer, because inputs will always come in the form of string. So input, and let us say number. This is our prompt in our input, so number. So this will give us the number, and we are going to use this n in our for loop. So let us give a space for some formatting over here, and let me bring this into little center of the screen. So for n in for I in the range n, we are going to get binary result, because we already have created the function convert number. We are going to say I comma 2, because that's our base. Octal result, we are going to take convert number I comma 8, and hexa result, and we are going to convert it into I comma 16. So if we print these three numbers now, we will get our required result. So if we say print, and if we write a thing saying that decimal is going to be, so let us write the format over here. Let's format the string in a way that we are able to print it. So decimal is I, because that's our variable. Binary, and let us keep printing it in new line, so we can see it in new line. Binary is going to be bin results, new line. I'm going to move this to F. So octal is going to be octal results, new line, and hexadecimal is going to be hex results. So now if we run this, it is going to ask for a number. So let us say we write 14, and now if you see, this gave the required result, but let us try to put this in a very good way in a tabular format. So, and I see there is one mistake over here. We went only till decimal 13, we didn't go to 14. So we need to do one correction over here, and that is going to be n1, and we need from 1 to n. So we are going to change this way. And if we now run the code, we are going to get, for example, let's try 4, because that's going to be easier to see in the screen. So 1 till 4. So we have got our at least required. Now we need to format our output. So to format that output, let us say that result format. So this will kind of make our output in a tabular format, and that is going to be F percentage 10 string. So I'm going to put 10 strings, and we have 4, so we are going to just multiply it by 4. So this is our result format. And now let us at least put a heading on top of it. So print result format, and we need to give the inputs for each of the string replacements in the string formatting. The first one is going to be decimal. So because this is a string, I need to put it in a string format. Second one is going to be binary. Let me make this little lowercase to maintain the uniformity. Second one is octal, and the fourth one, so that was third one. Second one was binary, third one was octal, and the fourth one is hexadecimal. So if we want to print this, so that is the heading. And now let us put our result also in the same format, so it looks nice. So let's get rid of this line, and let's say result format. So this is a result format, and then we are going to add our conversions, the replacements over here. So I is going for decimal, bin result is going to for the binary results, second one is octal, so octal results, and then the fourth one is hexa results. So, and we need to close this print bracket, that's why there was a red line. And now if we run the code, let's run the code. It's asking for the number 14 number, so we'll give it a 14. And now we see, now we have a tabular format. So we know that for 1, it's 1, for binary octal also 1, hexadecimal is also 1, and for 14 it was 1 1 1 0 16 and E. So we can run this program multiple times as if you want, and we can see the results. So let's run it for one more time, and let us give the output as 24, and we see that it prints in a nice tabular format. So in this example, or in this tool, so it can be a tool if you are using it for daily purpose to convert your decimal into binary, hexadecimal and octal for your work purpose. You can just simply run this, give out the number, and it will print the list of all. So we learned a couple of things, how to convert decimal into different base formats, that is different number systems, and the other thing was formatting of the output. So keep watching videos, like, subscribe, and if you have any question, you want me to solve any particular question, please put it in the comment section. I would love to solve that for you or help you with it. Thank you. Good luck till next time.